Hello, everybody. This is Nick Totiro, Professor of Information Technologies and Computer Science, Lakeland Community College. All right, let's talk about reading files in programming logic. Now, we're going to be using Python in the description, but most major programming languages have some form of reading files. In Python, which we're going to be demonstrating, it can basically read almost any file you can give it. There are libraries that will allow you to read Word files, Excel files, PDF files, but I want to go down that path. I want to keep it nice and simple. One of the beautiful things about Python is its ability to use and manipulate strings and text. And a lot of people don't do that justice, but we need to understand a text file is the lowest common denominator. When we're transferring data from one place to another, the lowest common denominator is some kind of text file. Years and years ago, changing files and doing input of files and stuff like that, they had all these different settings, and it was challenging. And then slowly but surely, the lowly old text file became our lowest common denominator. Every programming language should be able to read a text file. If you get into networking, you get into Linux, all of Linux configurations are text files. Now, some of them are hidden, but they're text files. You get into any of the open source, you get into Apache web servers or anything like that. They use text files as a form of configuration. So that lowly little text file has become so crucial in everything we do in the ITCS environment. In this video, we're going to examine some fundamental, or what I call simple, reading of text files. So let's go to my machine and let's start there. All right. I'm going to be using PyCharm on this. Again, I like to use PyCharm when we start getting into a little bit more advanced topics. This is not so much of an advanced topic as it's a very interesting topic that most people will use. Now, with Python, there's a couple things we have to keep in consideration when we're reading files. The first thing is opening and closing those files. We open the files. When we're done with them, we want to close those files. We could potentially run into resource allocations and problems and configuration issues with the computer when we're routinely opening up files after files, but we don't close them. There's also potential of data being corrupted, right? So it's just a good habit. And I'm going to be really honest with you. I've been working with these files for many, many years. I don't think I've ever corrupted or ever had a problem not closing those files, but it is a good habit to get into. So one of the first things we need to learn to do is open a file. Now, with that being said, generally speaking, when we're dealing with text files, there's three ways to read a text file. The first one, based on the easiest. The first one is just called read. And what that will do is it will take the entire content of that text file and it will store it as a string in the Python program. And that sounds great, but if this text file is very, very large, it's not an optimal approach. We usually use read when the text file is very small, or it could be a single line of data. A lot of configuration files, they will do things to text files that they'll only use like one line of the text file. So sometimes you open up what you think is a very sophisticated text file and you'll see the letter 1 there, or the letter 0, the number 0 there. And what will happen is a program will open up and it says, if that file has a 1 in it, do this. If it has a 0 in it, do that. So the use of the read, where we read the entire content into a string, is a very valid approach. We tend to use it for configuration types files or files that are fairly small. Let me take a look at my machine. All right, I have this file right here. It is called this file right here. Don't worry about the naming convention that I use. It just kind of keep things in a sorted order. But I'm going to call this simple read. And all simple read does is it opens up a file, reads the entire content of that file into a string prints the string, and then closes the file. So if I was to break this down, it's 4 lines, now not counting the comments, but here is the first thing in the Python, is opening up that file or creating a file object. And we can call it anything. I use an F just so it's a file. I can call it anything I want. And I say open, and I give it the file I want to open. Now this particular file here, it obviously is a text file. It's 99a_1_password.txt. That is a, let me open it up, go all the way down. If I was to open it up, you can see it is 1 line in there. So that's not a bad thing to do or to use that read function. So when I run this, it's going to open up the file. Here, it's going to read the entire content of that file. If that file is a book, it's not probably a good thing you want to do, but it would try to take the entire content of that file, put it into a string. Because it's only a couple characters, that's not an issue. I'm then going to print it, and I put the type there just so you can show you that it is going to be as a string, and then we close. It's important to close to ensure efficient resource management, maintain data integrity, et cetera, et cetera, et cetera. Let's run it. It's going to be boring. Give it a second, and there it is. It's a class string, and inside that string is a word called password P&SSW0RD. Good. What if we have more data? All right. We have to ask our question, how are we going to use that data? If it's just string, and for this one, it's just going to be strings and it's going to be pretty much the same things. Let me paint a scenario to you. You are given a list of passwords and you want to prove that these passwords are strong. You want to kind of store their hash value. So I have a couple files that are going to have passwords in them. One of the files only has 1 password. Another file has 1,000 passwords. Another file has 10 million passwords. That's a big file. And all we want to do is we want to read the password, determine its strength, run it through an algorithm, determine its strength, and then create a hash value that if that password ever changes, the hash value would change. Very common approach when we're working in cybersecurity and looking at passwords and trying to figure out password strengths and doing data analytics on that stuff. So we have 3 files. One is 1 password, one has 1,000 passwords, one has 10 million passwords. So obviously right here, I did the one with the read. That made sense. If I was to take even the one with 10,000, the one with 1,000 passwords and put the whole thing to a string, there's not much I can really do with it at that point. So the next one, the next file we're going to look at, I'm going to close some things up, clear them off here, is the read lines, READLINES, read lines. Now what this one does is it looks at the entire text file and takes each individual line that's determined by the line separator, the new line command, and puts that into a list. So what that allows us to do is then take that list and use it for multiple locations inside our program. It's like a list of anything else. Now, we want to be very careful because now we're kind of dealing with memory constraints. A thousand item list is not that big. So that's not going to be a bad option. And then what we can do with that list is we can iterate through it. We can use it in several locations in our program, but the key is read lines, plural, will look at the entire text file line by line, regardless of what the lines are, line by line, and put each one of those lines into a separate item into a big list. It is a great tool. Probably of all these, I use this one quite frequently if I'm looking at certain things, if the data is not too out of control, 1,000 lines or 1,000 passwords or 1,000 emails, even a couple thousand. We start getting more, then we can get into memory constraints. So here is the program. And here's the pretty much the same line for opening it. It's F, that's going to be the file object name. Open the file that I'm looking to do work on. I happen to have a file here called 99b underscore 1000 passwords.txt. I didn't point this out before, but that quote R just means this file is going to be read only. And that's how the operating system can make things more efficient when it's reading things. Internally, when the operating system is working on things, if it has to open up a file as a read-write file, it has to take a lot of things into considerations, because what if multiple people are trying to hit that file at the same time? By telling it this is only a read-only file, it's going to leave the file alone and be very efficient by just reading the content of that file. And right here is the line of interest for us. In this particular line, it says read all lines in the file F, read all the lines and put every one of those lines as a unique entry into a list. What I did, because now it's a list, I did a little sort here. Make it a little fancy. So the list is going to be sorted, and then I'm going to print out the list. So you're going to see the list, but it's going to be sorted. All right, so let's run this. Give it a second. And you can see that it's registering as a list. Here's the first item, second item, third item, and it is in sorted order. You will notice that each one of those does have the new line character in it, which we would have to take into consideration. We can just strip that out, but I left it there and I said, okay, all this does is it looks at the entire document and puts that into each line into an individual item in a list. We still have to be careful, because if the text file is extremely large, very, very big, there's a good chance I'm going to run out of memory allocation here. I'm just going to run out of memory if I try to force too many items into a list. So if the file is really big, sorry about that. If the file is really, really big, for example, if I'm looking at 10 million passwords, this would not be a good option. This is a great option if I'm doing a lot of stuff at the same with the same information routinely throughout the program, right? So let's go to the big one, or let's go to one that you're dealing with a situation where you're dealing with a very large text file, 10 million passwords. And yes, I am working with a text file down here. If I open it up, it's so big that it won't allow me to do certain things on it. It's going to warn me, oh, there it goes. This file size is 8.53 megabytes, exceeds the limit on my machine of 2.56. There's not much I can really do with this, but it will allow me to read it, right? So that's a good thing. But you can see, it'd be very difficult to take these 10 million passwords and put them into a list and then manipulate them. So what I'm going to need to do is use the read line. And what the read line function does is it grabs one line from the list. That's it. And then if I want another line, I have to tell it, grab another line, and then grab another line, then grab another line. So I have to iterate through the entire file to get everything associated with that file. It's not going to put it in a list, so I'm not going to be able to reuse it, but it's more like a one-time pass, right? Or anytime I need to use it, I have to go through the entire listing. I have to go through the entire listing of that text file over and over and over again. So, but this is very efficient when you're dealing with very large files, because it takes a line, does something, goes to the next line, takes a line, does something, goes to the next line, etc., etc., etc. So let's take a look at this. We've seen this one before. We're going to create a file object called F. I can call it anything I want. I can call it junk. I can call it file. There's no magic to the character F. I'm going to say open up this file here, this 99C underscore 10 million passwords.txt. My naming convention I just put there so they sort on my screen a little bit better. The 99 has no bearing except it moves everything down to the bottom. No big deal. I read the first line. Boom. Then I get into a while loop. And what the while loop says is as long as there's a password, meaning as long as there's content to that string. So I read that first line and I put it into a string variable. The while statement says as long as there's something in that string, as long as you keep on getting me stuff for that string, I'm going to keep looping through here. The moment you don't have anything, you hit the end of the file, there won't be anything in the string, the while loop will stop. So this is if you remember from previous, this is a conditional situation. It will stop on the condition that it runs out of stuff. I print the password. Now this time I do strip out the new line because it will just put blank lines on my screen. And like other while loops that we saw in other videos and class discussion, get another line. So this is going to go through 10 million passwords. Now, let me explain something. My machine is horribly slow. It's an older machine. It's probably 3-4 years old, does wonderful things for me. Can't ask for much more than this, but it's not the most powerful, robust machine I could be using. That's fine. You're going to see this Python program, because of the efficiency of how Python deals with text files and because it's read-only and a bunch of other things, it's going to go through 10 million passwords relatively quickly. I couldn't put those in memory, but it's going to go through those passwords relatively quickly. And there they go. It is going through. Now, if you're curious, let me wrap things up here. If you are curious, what I'm trying to do here is I'm using live password files. It's a common approach in cybersecurity to look or review password files. We use them in brute force attacks, dictionary attacks, and things like that. But as hopefully people get better and better, stronger and stronger passwords, these brute force attacks begin to kind of fall to the wayside. But we have to determine if those passwords are strong enough to be considered into a brute force attack. Now, the passwords that I'm using in these demonstrations throughout these videos, these are the top 10 million passwords that have been discovered out there on the internet. So these are live passwords. These are passwords that people have used that the hacking community is well aware about. The top 10 million passwords we have lists for. So all I want to do is manipulate that or see or do some data analytics on it, find out their strength value and find out a SHA value. So the first thing I had to do was I had to open up the files. In subsequent videos, we're going to build upon the complexity. So with that being said, let's go and learn something.